let's do this. Mr. Scott, this is your turn, my friend. So Scott sent me up his 667. Now this is just a straight 667. It's not a 667V. Okay, the V stands for variable. We all know that. This amp will not do the wattage that it is supposed to. We changed out all 4 of the 2879s, but did not change out the driver. Do you think, and make it a hot box? Please check the bag of pills, which we did. Please check the bag of pills I sent. Any questions, please call me Scott. Okay. So Scott, this is your 667V. We're going to change a couple things in here. When they changed the pills out, so now I got on the phone right after I got this box out and took a look at it, and I talked with Scott on the phone. They changed the transistors out to DEIs, and if we look down in here, we'll see that they just got black tops on them. Now, through experience, Scott told me something, and the experience kicked in and told me what they were. Scott says, well, they came out of an old Ranger board. Well, for about a hot minute, they were putting DEIs in there, and they were black topped. They didn't have any labels on them. So I went over here and I checked all the transistors that Scott sent up in the bag, which, well, 40, a 16, a 15, a 15, a 40, and a 30. So this matches with that. We're going to set this aside. So Scott, you're going to get back all the transistors that are over here. And I'm going to put these 4 transistors back in their spot, because the Toshibas are better than these blacktop transistors any day of the week. Any day of the week. Now the other thing Scott told me is he wanted to convert this thing over to be a high drive, so you could use it with like a Connex or his Ranger radio or a Stryker. And we're going to show how to do that here real quick, which is real simple. We're going to bypass this input pad circuitry, which is this resistor, and this resistor. We're going to remove these and set them aside. We're going to disconnect this wire, and we're going to take a piece of Teflon wire and go from here to here. And that'll make it high drive. So it'll make it just like a Texas Star like 500, I think. Yeah, Texas Star 500. We're going to do some power wire upgrades, and then the other thing is I got to clean all this black schmew that's down here. This thing's been burnt up. But look at the lid. Inside the lid we can see we've had an explosion of some kind at some point or another. And it's right around this output tuning section. So that tells me this thing has been burned up hard once or twice in its life. And it's usually the combiner that burns up, this little tiny combiner, which we might take this out. I know that we're going to replace that little 2 watt that's down in there. We're going to get you a new one. That's actually a 1 watt, 1.5 or whatever. We're going to probably put a 5 watt in its spot, and we're going to clean all the carbon score up. The carbon score, we've got to get the carbon score off the board, okay? Because carbon is conductive, highly conductive. And if we leave the carbon score on the board, the chances of this happening again are pretty high. Now, as we can see, the coax is pretty burned up and chooched out. Even if we clean this up, the chances of the coax failing are pretty high. So what I'll probably do is I'll come in here and I'll replace this with some 316 coax, make it all nice and pretty. We'll get this all set up for you and ready to go. Now, what I did want to do, and the reason it's not putting out the power it should, and the reason that we're having an imbalance issue, it's pretty obvious to me anyhow, is this capacitor right here on the output transformer. See how this one's standing up and it's soldered to both of the transformer tabs? This is really common. The transformer, or the capacitor gets really warm on top of that transformer, and it gets hot enough because there's no airflow across the top of the components to where the capacitor falls over. Well, that capacitor's not physically hooked up. It's like if we can get in here at the right angle. Yeah, that's it. There we go. We'll see if we can get it to focus down in there. You'll be able to see as clear as day that the capacitor's not connected anymore. You see that right there in the middle of the screen? So that causes this circuit to not be balanced in resonance with this portion of the circuit. Okay, so you have this separate 2-pill section and this separate 2-pill section. This section is going to produce more power, because it's more in resonant with the component than this circuit because that capacitor's come loose. So I'm going to resolder that cap, change the transistors, probably do some power wire upgrades. We're going to bypass the fuses, which are going to make a huge difference in power output. And we're going to clean this mess up. So let's go ahead and test it before we get any further into it. Now, I'm using the 2950 5-watt slug from the 2950 down to the 667. Now we already know that we're going to get a defunct reading off of this. All right, we're on 14 volts. So let me show what I'm putting into it for drive. 1000-watt slug in peak, 1000-watt slug in average, 5-watt slug in reverse. Hold on, let me turn my mic gain up. I was using it to test something last night. All right, here, ready to go. Here we go. 20 whole watts on 14 volts. Nothing there ever changes. I turn the 667 on. Now remember, you've got high. When you turn the amplifier on, it's on high. And then you got your preamp. Then you got medium, and then you got low. Each one of these switches engages a different level of attenuation. So this is medium, which your light bulb is burned out, and then low, and then sideband. So we're going to just try it in high. Hello, audio. It's about 400 watts. Now we don't want to key it any more than that, just that one little quick key, because the output is in balance. So look at that. Just that one little quick key has made the combiner get that hot. So technically, only half of the amplifier is working, which is this side. Okay, so we're getting a little bit of wattage out of this portion. Most of the wattage is coming from here. About 300 watts is coming from here. Maybe about 75 to 100 watts is coming from here. If I take this cap and just hook it back up, we'd probably be around 500 or so watts. All right, we got all that out of the way. Let's do our thing. Scott, we'll be back. Okay. Mr. Steve here, this is where we're at. This is where we ended up. I went ahead and changed out the transistors, of course. As you can see now, there's Toshibas that are down in there. Two there and two there. I replaced the coax and I cleaned all the burned shmew out of the corner of this board. Cleaned it all off, got that all cleaned up. Replaced your coax with dual shield 316 input. I went ahead and I did a power wire upgrade, complete. Now don't freak out. Here's your stock zip wire. I'm just not a big fan of this stuff, okay? So I'm going to send you back your terminals. Now, looking at these terminals, I want you to see how hot they got. Come on, camera. These things got pretty warm, which means that they're restricting the amount of amperage that can flow through them. So you might want to get some bigger eyelets to put on them. But this wire here is the exact same length as your zip wire, okay? Except it's got twice the amount of cable in it, and it's flexible, okay? Now we went in here and we bypassed your fuses. We gave you that power upgrade. We replaced the pressure grommets with regular rubberized grommets, and then we washed it. We literally washed the whole board and took all the flux off it. That's the reason this thing looks so shiny and clean and pretty on the inside. And of course I put it back together very meticulously. I want to show you something here, Steve. We're going to hit it with our 2950 again, just like what we did in the first video. But, 650 watts. Average power. Audio. Here's our input tune. Now, I spent some time totally dinking around with this attenuator setup they have here. And it makes sense. They're compensating for not having the variable. With 1 watt dead key, and I bypass this, take this wire, go to ground, take this wire, hook it up here to the switch, it'll dead key like 450 watts and swing forward to 600. Now, the last little bit of this equation is Steve wants me to convert this to a super high drive. He's got like a 150 watt radio-ish that he wants to put in it. So the radio I got on the workbench to emulate that is the Connex 4400. So Steve, your results may vary based on how much drive that radio puts into the amp. But we're going to see 600, okay? Now, one of the other things that happened is this cap blew up, At some point or another, somebody's hooked this up backwards, and they've replaced that diode. And there's no one on this board, but it was hooked up backwards because none of this stuff was right. Like, there was a little electrolytic capacitor that's supposed to be there, and the only thing that makes that thing chooch up is if either RF gets into the positive rail, or it gets hooked up backwards and that cap pops. Usually this diode goes, but the diodes that they put in here stock are black. That one's red. Changed out the power wires feeding all the sections, so I gave it all the power wire upgrades, and had to add a couple little things. Had to add a capacitor on the output to get the output to come up. There's supposed to be a cap here, and that cap gone to dirt. We soldered this back the way it was supposed to be, and like I said, with 20 watts of drive, so anywho, now that we got the box working as it sits, excuse me, we're going to disconnect these wires, and we're going to take a wire and go from here directly to here, and then we're going to drive it with this. And then we're going to change the input tune probably, because they changed the tuning a little bit. We're going to have to change this cap out that's right down here. Make sure our input tune's nice and flat. So anywho, give me just a minute. This won't take nothing to do. I'll be right back. Steve, she's all done, man. She's converted to high drive, and all you got to do to convert it back is take this wire, tie it here, take this wire, tie it here. Remove this black wire, and take this wire, go to here. Pardon me. Take this wire, go to here, where this black wire is attached. And you move back to high drive. I did have to change the capacitors. Your stock tuning capacitor is right here soldered on the board, so if you ever wanted to convert it back, you can. Your relay connections have been cleaned, and bada bing, bada boom, you're all done. So Steve, we're going to take the Connex 4400 and shut the amp off. Hello, audio. Hello, audio. Hello. Put about 50 watts peak into it and about 130 watts worth of drive. Hello, audio. Hello. 600 watts in output, approximately 300 bird. And let's see. Hello. 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 Less than a half a watt input reflag. That's it. I'm going to put the tin on it, and it's coming back to you, brother. I'm going to send home the stock power wires with it, and then your bag of transistors, which has got the Toshiba or the DEIs that came out of this, I'm going to send them home with it. So you're all cleaned up. Gentlemen, fun as always, and on to the next project. I got 3 more that I want to get done tonight, so we're going to see if I can get them all done. I doubt it, since it's 1:30 in the morning, and I got to do the video editing for this thing. Then I got a Killer Bee, and then I got a 12 pill I got to go rebuild. So, away I go. I appreciate y'all tuning in. If this is the first time you've ever watched one of my videos, please make sure to subscribe. I greatly appreciate it. On to the next show. I'll see you guys. Bump, bump from the biggest mud duck in Idaho. I'm 10-7. I'll see you. Bye-bye.